So far we have seen that what is the difference between modern physics and classical physics. Then we have gone through the introduction of photon, its definition, energy possessed by photon, and so on. Then we have seen that light travels in the form of particles. That particle is known as photon. But we didn't discuss about that experiment which actually proves that light shows particle nature, and that experiment known as photoelectric effect, right? So this is our next topic, photoelectric effect. Like I have just told you, this effect and this experiment shows that light is also a particle. Okay, then that particle is like chunk. Just imagine these are the small packets, right? And each packet consists of energy which is given by h nu. We know that h is Planck's constant and nu is frequency of the radiation. This way. Now this behavior of light cannot be explained by classical physics, right? So we need quantum physics to explain this behavior. Now how we are going to deal with it? First of all, we will conduct the experiment of photoelectric effect. We will have an experimental setup. We will discuss over that. Then we will see what are the observations. Then with the help of that observations, we will compare our result with the classical physics. Some of the results will match, some of will not, and then we will conclude something, right? So before going into the quantum physics part, let us discuss the experiment and the observation from that experiment. So what will be covered in this experiment? Understand the photoelectric experiment, what results you would expect if light were a classical wave, like I have just told you. Like physicists at the time expected the experiment should give, right? If light is a classical wave, we should have the result same as the classical wave give us, right? But if we have the different results, then we have to approach that concept in a different way. Okay, fine. So this is the experimental setup for photoelectric effect experiment, right? Now you can see here, here there is a tube and a small opening is here, right? And here there is a plate named as C. Okay, let me tell you, the C is cathode and this plate A is anode. As all of you might be aware of what is cathode and what is anode. Cathode is the plate which is connected to negative terminal of the battery. Anode is the plate which is connected to positive terminal of the battery. That's it. So this way we have this arrangement. Okay, and what will happen? See, through this opening, the light radiation will enter, right? When light radiation will enter through this opening, it will fall on the cathode plate, right? Now cathode plate is nothing but it is a metal plate. So when this radiation falls on the metal plate, what will happen? We will see that there is a small current through this circuit after some time, right? What is happening deep inside, we will discuss it later on. Here we are just discussing the things which are, which are giving us the result. So when the light enters through this opening and it falls on the cathode plate, we see that after some time we get the current in this circuit. Okay, now how we are going to have this result, what are the characteristics, what are the factors of that incident light radiation we are changing to have that result, all of this comes under the various terms. So let me discuss those terms first of all with you. Okay guys, so what's happening here? So first thing which I need to discuss is threshold frequency. Okay, now if if I incident the radiation of particular frequency here, for example, let us say 20 hertz frequency radiation is there, and that radiation is incident on cathode plate. I see there is no current in the circuit. Then I increase the frequency up to 40 hertz. Then I see again no current in the circuit. Then I increase the frequency up to 50 hertz, and I see that with this frequency I am having a small amount of current in the circuit, and when I increase the frequency again I will be having the current in the circuit. That means here there is a minimum value of the frequency is needed to get the electrons come out of the metal plate, right? Why there will be the current? Obviously when the electrons from metal plate will come out and they will conduct the current through the circuit, right? So this is the minimum frequency required to get the electron come out from the metal plate, which is called as threshold frequency. Okay, so I should mention here that it is minimum frequency. When incident on metal plate, electrons come out from the surface. Okay, then what I see is when I increase the intensity of radiation, right, I get more and more current in the circuit. But at some particular value that current gets saturated. That means after that value that current has the constant value. For example, if I have the constant value for the current is 1 ampere, then that means after that you increase the frequency or you increase the whatever the value, that current will become constant. So that current is known as saturation current. So we will call it as maximum value of current. Thereafter it becomes constant. That's it. Now as we are performing this experiment, okay, we are increasing the frequency, we get that value of threshold frequency, we get the current in the circuit. Then the further increase in the frequency, there will be no change in the current, it will gain the constant value which we are calling as saturation current. What if we need to stop that current? Then what will we do in that case? In that case, we will decrease the potential of anode. That means we will make anode with lower potential with respect to cathode, so that the electrons will not hit the anode here. Okay, we will make the potential of anode as negative as possible, so that electron will not be able to reach the anode. Okay, then if I am changing the potential of anode, right, potential of anode negative, right, I am giving the negative value to it, so that the most energetic electron will also not be able to reach the anode. Obviously then there will be no current. Okay, and that's what we need to stop the current, right? So we will have that value of potential where it will stop the most energetic photon as well. So we call that potential as stopping potential. we can define it as it is negative potential of anode so that the most energetic electron is not able to reach the anode. Now, why I am calling it as the most energetic electron? Because each electron which are emerging out from the plate will have different kinetic energies, right? So, if I can stop the most energetic electron, then obviously the other electrons will be stopped, right? But if I pick a particular amount of energy with that stopping potential, then it is able to stop only some of the electrons and the most energetic electron will be still there to conduct the current, right? But we don't want that. We want that current should be zero. So, we should have that maximum potential at which the most energetic electron will also be stopped. So, that is why we call it as stopping potential. Okay guys, so we have covered almost all the necessary terms in this experiment, and we have also seen that what is happening here, right? Afterwards we will see what are the relation between all of these quantities like frequency, intensity and stopping potential, kinetic energy and so on. Okay, now what observations we have made with this experiment? Okay, so first observation is related to current and intensity.